Hi there, it's me, Ditto. You're probably wondering where I am right now. I'm in the city, and unfortunately, the all gas slowed down time. It seems that I'm the only one who's not affected by this.
Ha! To bring back the correct flow of time, you must solve these three problems. Right now, these three problems are also affected by the slowed time, which means you have to solve them as soon as possible, otherwise it would be unsolvable.
Alright, I got this.
These problems involve related rates, which means you have to solve for how fast a variable is increasing or decreasing. One of the variables' rate of change is given while the other is unknown. That is what you have to solve for.
So, this first problem involves a ladder that's falling down a wall.
As you can see, this 10.5-meter ladder is leaning against the wall of this building. The base of the ladder is sliding away from the wall at a rate of 3 meters per second. The question is, how fast is the top of the ladder moving away down the wall when the base of the ladder is 7 meters away from the wall?
Seems easy. Let's start with the given. You said that the distance of the ladder's base from the wall is 7 meters. We'll represent that with x. Then the length of the ladder is 10.5 meters, which will be represented as z. And lastly, the speed of the ladder's base sliding from the wall is 3 meters per second, which will be represented as dx over dt. Right now, I need to solve for dy over dt, which is how fast the top of the ladder is moving down the wall. But I need the height of the wall that's touched by the ladder, which I will represent as y. Now that we have the given, let's solve for the y. To solve for y, I'll use the Pythagorean theorem. That will be x squared plus y squared equals z squared. Substitute our given values, and we have 7 squared plus y squared equals 10.5 squared. If we solve for y, we first transpose 7 squared, evaluate, and we get y is equal to 7 square root of 5 over 2. Now, to solve for dy over dt, we need to first differentiate the first equation. We will get 2x dx over dt plus 2y dx over dt equals 0 because z squared is a constant. We will get a new equation from that. Now, we substitute the values and then evaluate using a calculator. The final answer is dy over dt equals 2.683 meters per second.
A spherical balloon is being inflated at a rate of 200 cubic centimeters per minute. How fast is the radius of the balloon increasing when the radius of the balloon is 2.5 centimeters?
Let's start with the given. We have dv over dt representing 200 cubic centimeters per minute. Small letter r representing the radius, which is 2.5 centimeters. The formula for a sphere's volume is 4 over 3 pi r cubed. And I have to find dr over dt when r equals 2.5 centimeters. First, I differentiate the formula for the volume of a circle. dv over dt equals 4 over 3 pi multiplied by 3r squared dr over dt. 3 will be cancelled, so we're left with 4 pi squared dr over dt. Now, we substitute. It will now be 200 equals 4 pi times 2.5 squared dr over dt. 4 pi times 2.5 squared becomes 25 pi. Then, we isolate dr over dt. dr over dt equals 200 over 25 pi. Evaluate, the final answer will be dr over dt equals 2.546 centimeters per minute.
Last problem, we won't solve this one. This cylindrical container is being filled with oil at the rate of 305 cubic centimeters per second. If the radius of the plastic container is 27.5 centimeters, how fast is the height of the oil rising in the container?
Let's start with the given. The radius represented by r is 27.5 centimeters. The container is being filled at 300 pi cubic centimeters per second. Represented by dv over dt, the formula for a cylinder's volume is v equals pi times r squared times height. Let's substitute and evaluate. And then we'll have v equals 756.25 pi h. Now, we differentiate this and we get dv over dt equals 756.25 pi dh over dt. Substitute and get 300 pi equals 756.25 pi dh over dt. Isolate dh over dt and we have dh over dt equals 300 pi over 756.25 pi. Evaluate and the final answer is dh over dt equals 0.397 centimeters per second.
That is very impressive. You solved all the problems.
Yes, now return time back to its normal speed and go back to your land.
Fine!
I hope you learned something in this crisis and the problems we solved. Remember, related rated is all about finding the rate of a change of a variable, like how we solved for how fast the ladder was falling and how fast the water is filling up in the container. Well, that's been it. Now that Dialga has been defeated, we can all go back to our normal lives. Stay safe and study calculus. Goodbye!